So number 5 here. This year, a company produced 4% more items than last year. If the company produced 26 items this year, how many items did the company produce last year? Okay, so first off, they're asking us which equation will help us solve this problem, and then and then at the bottom, they want the actual answer to the problem. So this is a tricky question. How are we going to do it? In fact, let me, well, no, we'll leave it as it is. So, yeah, how are we going to answer this question? It's kind of tricky. Let me show you some wrong ideas, which sounds funny. Is that a good way to teach? It actually is sometimes. It's important to know not only what's right, but what is not right and why it's not right. That's part of learning. So here's what I've seen over the years is students will go, okay, I got it. It's 4% of the 26. This is wrong. This is not true. But students think that. They go, well, you just take 4% of the 26, which is 0.04 times the 26. 0.04 times 26. That's 1.04. And then you just, well, hold on. Let's see if this is making sense. So we had last year. We had last year, and then we had an increase, right? 4% more. 4% more. And then we have what? Oh, 26 items this year. And then so then we have this year. Okay. So you tracking with me? So we have last year, and that's what we don't know. 4% more, and then we have this year 26. So it went up. It was an increase. 4% more. Right? 4% more. So we have last year, which we don't know. We're trying to find out. That's what they're asking us about. They're saying, hey, how much did the company produce last year? We know that they this year they produced 4% more, and now it's at 26, right? 26 items this year. So we don't know what last year was, but they got 4% more, and this year it's up at 26. So what was last year? Well, some lower amount, right? You with me? Last year had to be a lower amount because they produced 4% more this year, and now they're up at 26. So what was last year? Well, a lot of students make the mistake, this is wrong. They'll go, oh, well, you just take 4% of 26 because it went 4% more. Get it 1.04, and then you just subtract. You just take 26 minus 1.04, and that comes out 24.96. It must have been 24.96. That is wrong. That is not true. How do you know? Why? Why is that wrong? Well, check it. Let's check it. Let's check it to prove it. This is the best thing you could do is learn to check your own work more and more. If that was really true, it's not. If that was really true, then 24.96, 4% more, multiply by 0.04, right? 24.96 times 0.04. I'm getting 0.9984. And then, right, I just took 4% of it, right, because they said it went 4% more. Then I should be able to add the 0.9984 to the 24.96, and it comes out 25.9584. That's wrong. It's supposed to be 26. You might think, oh, that's close. It must just be decimal rounding stuff. No, it's not true. It's not just decimal rounding stuff. It's wrong. It's just not right. Do you see it? Do you see how I just proved it's not really the truth? It's false, wrong reasoning, untrue logic. mistaken thinking. You see that? You might say, well, it's so small, it's close. Well, if we're talking millions and billions of dollars, it would be a huge difference. So it's not right. You see how the check proved it's not right, right? I say, well, if the answer, if it was really 24.96 last year, and they went 4% more, then multiply by 4%, you get this, add this to the 24.96, it does not become 26, which is what they told me they're at this year, 26. So no, that's not right. Well, what happened? Why didn't it work? We took 4% of 26. That's what they said, 4%. And then we subtracted it because it was less last year, and then 24.96, but then somehow this weird check thing didn't work. What's going on? Why is it wrong? Why isn't this 4% thing working right? Isn't that what we're supposed to do? 4% of 26? No. Why not?
Would it be because it's supposed to be 4% more than last year? So it's like it should be adding or
Right. It's what it's the percentage of is the trick. You're supposed to take 4% of the last year amount, not of the 26. Do you see that? It's 4% of the last year, not 4% of the 26. That's the mistake being made. Do you see that? That's the mistake being made. Like, for example, let me show you, before I go on to the right answer, I really want to drill in why this is wrong, because tons of people make this mistake, and you'll teach younger folks who will get confused by this as well. So it's really important when you're teaching to be helpful to people when they have a certain thought and they really think it's right, not only to tell them the correct answer, the correct method, but to address their thinking, because that's what's really in their mind, and to help them to see the part of their thinking that's actually not true. That, that's not putting them down. Let's don't get into our feelings here. This is about what's true and what's false. That's what I enjoy about math. And, gently, kindly show them why their logic is false, and that will help them. You'll be doing them good. That's kindness, actually. You'll be showing them and improving their thinking. That's helpful to me. I have thought a million wrong things about math and many other things throughout the years, and as people and websites and books showed me where I was wrong in my thinking improved. That was helpful to me. So one more time, let me show you why this is false. Let me take a simple example of $100. Nice, easy number. What if I took $100 and I increased it by like 10%? Let's take it. I just want easy numbers because we can just kind of do those in our head. What's 10% of $100? Isn't it $10? Right? $10. So if it increases 10%, wouldn't it be at $110? That's simple math, and that's true. That's right. I'm not saying anything false. That's true, right? Take $100, you increase it 10%, it goes to 110. That's 10% of $100. It went up $10, right? Okay. Well, is that the same thing as going back down 10%? What if I decrease it by 10%? What's 10% of $110? Well, that would be $11, wouldn't it? Right? You just divide by 10, just move the decimal one spot over. $11 is 10. So you'd go down 11, you'd go down to 99. If you went down $11, right? Because $10 would take you down to 100, right? From 110 down 10 would be 100, and 11 is one more, so you'd be down to 99. Notice that's not the same thing. To go 10% increase is different than a 10% decrease. Why? Because we took 10% of the 100 to increase. So it's not the increase decrease. That's not the problem. It's what you're taking the percentage of, you see. If you take 10% of $100, that's only $10, right? But if you take 10% of 110, that's $11. That's different. It matters whether you're taking 10% of the smaller number or 10% of the bigger number. Obviously, I mean, now that I say it, you're like, well, of course. Well, that's the issue. When we do this right here and we take 4% of the 26, we're taking the 4% of the wrong thing. You're supposed to, the 26 bucks is the final price. That's not what we're taking for, what we're supposed to take 4% of. We're supposed to take 4% of the original price, right? It increased 4%. So we need 4% of the original price. Well, we don't know the original price. Right. So we're going to call that X, and we're going to have to use algebra. That's what makes this a harder problem. That's why they're showing us all these formulas here, because it's going to have to use an X, because we don't know the last year's price, but that is what we need to take 4% of, right? That's how percentage increase works. You take 4% of the original price, not 4% of the final price. That's the mistake. You can't do that. You can't just take, you can't say, well, it went up by 4%. That's the same thing as going down by 4%. No, it's not. This proves it right here. Going up by 10% is not the same as going down. They wouldn't go back to the same number, would they? Do you see how that example proves the falsity of that thought? So that's important. A lot of people are confused by that thought, and younger folks will be, and you'll do them a lot of good service if you can spend time clarifying that thought for them. What you take a percentage of matters. Is it 10% of the 100, or is it 10% of the 110? That's not the same thing, right? The same percentage of a bigger number is obviously more. Okay, so with all that said, what in the world is the right thing to do? That's all the wrong thing, but a ton of people make that mistake. So I wanted to show it clearly and carefully. Okay, well, let's go back and do what's right then. So back to the question. Here is the question. We have the last year amount, X, and we need to take 4% of that, don't we? So we've got to take the original X plus 4% of X, and we want that to equal $26. That's our equation. It's right here. And then we got to solve that equation for X. Let me write out a formula to help you with that. Here's the formula that I found is helpful to students over the years. That is old price plus a percentage times the old price equals the new price. That's how you do percent increase. That's a formula that will help you do percentage increase. You've got to take the old price, which we don't know, so that's X, right? That's what we're trying to find. The last year price, we don't know it. That's the question mark. That's the X. Plus, because that's the increase, a percentage, 0.04, right? Times the old price, times X again. There's X again, right? It's the old price plus the increase on the old price to equal the new price of 26. That's the formula you want to use. And if they, by the way, if they change it to decrease, because they'll do that sometimes too, they'll put something on sale or something like that. That'll be the old price minus a percentage times the old price. So it's the same formula. For decrease, it's minus. For increase, it's plus, because increasing adds and decreasing subtracts, of course. So there's the formula we need to use. There it is right there. Now let's solve it. So yeah, draw a nice clean line here, and let's solve that. So we have X plus 0.04X equals 26. So there's the formula we need to solve for X. That's the correct thing to do. That's the old price plus 4%, increase. You take the old price and increase 4% of the old price to get the new price of 26. How do we solve that for X? Well, over here, you have to remember there's a invisible 1 in front of that X. So 1X and 0.04X is 1.04X. You just have to add those together like terms, kind of like 2X and 3X makes 5X, or X plus 7X makes 8X, because there's an invisible 1 there. That's what I basically did. I just added like terms, remembering there's an invisible 1 in front of that first X. So 1X and 0.04X is 1.04X. All right. And now, what's my last step to finish solving for X there? How do I get x alone?
You
Remember
would
your
divide it
algebra?
by 1.04x.
Yeah, divide, right. Divide by the 1.04. There we go. And we've got it. Use your calculator. Take 26 divided by 1.04, and you'll get a nice clean 25. So there we go. That's a harder problem. That's how you solve it. How do you know when you're supposed to do all this? Percentage increase or percentage decrease. That's when you have to do these. In fact, let me just put a box around the whole, both the formulas there. There we go. Percentage increase, percentage decrease. There's the formula you want to have in your notes for a percentage increase or a percentage decrease problem. You got to do all that. And the whole key is you've got to take the percentage of the original, not of the 26, right? We're increasing the original, the last year price. Well, we don't know the last year price, right? That's why it's 4% of X added to the original X to equal the new price of 26. The mistake people make when that old price isn't there, they just go ahead and think they can take 4% of the 26, but you can't do that. That's not the same, right? You take 4% of a bigger number, that's not the same as 4% of a smaller number.